Today I'm going to teach you how to do something called completing a square. And this really has a lot to do with some stuff we've talked about before. So I want to go back and talk about that stuff so it's fresh in your mind. Because I think that'll make today easier with the stuff that we're doing. Okay? We've done stuff like this before. Do you remember doing stuff like this before? Where I said, here is a trinomial, right? What did I ask you to do with this trinomial? Yeah, usually I ask you to factor it, didn't I? Okay? But I want you to look at these trinomials that I have for you today. Okay? These 6 trinomials, plus many, many more, are a special, very special kind of trinomial. Do you notice anything about them? They're what?
Quadratic. No, they're parabola.
Well, they are quadratic, okay, that's good that you know that, but if they're a trinomial and I'm asking you to factor them, then hopefully they're quadratics, okay? What'd you say? The last number is squared, and every single one of these, the last number is squared? That's important, right? Okay? That makes these, well, the last number is squared, and what's true about the middle number?
It's 2.
When they're set up like these are, you guys are all saying the right things, okay?
Same thing.
I know. When they're set up like this, that makes them very, very special trinomials. They're called perfect square trinomials. Okay? Perfect square trinomials means I can factor this. Now, I'm going to do the first one the long way. I'm going to do way too much work on the first one, so that the rest of them you can see what's expected of you so you don't do too much work. Fair enough? Okay? So if I ask you to factor this first trinomial, what would you do first?
We're probably going to take divide both.
So we say divides, wait, what? Multiplies to be 9 and adds to be 6?
Yeah.
Okay. What multiplies to be 9 and adds to be 6?
3 and 3.
3 and 3. So x plus 3 and x plus 3. Okay, that is way too much work. Why is that way too much work? What do you notice about the two factors?
They're the same.
They're the same. So can I write it a different way? How can I write something that's something times itself? X plus 3 squared. Okay? This is the trinomial. What's this called? A squared binomial, right? Trinomial is 3 terms, binomial is 2 terms. This, for a lot of our stuff that we're going to do today, is our goal. It's not the end goal, but it's a really important goal to get to. Okay? So we need to be able to go from our trinomial to our binomial. If we have to do this middle step, go right ahead. But hopefully we can get to where we're going from the trinomial straight to the binomial. Okay? So what about this one? Can you go straight to the binomial here? What multiplies to be 25 and adds to be negative 10?
5 and negative 5.
5 and negative 5? I thought it had to be exactly the same. Negative 5 and negative 5, so what binomial am I going to write?
X minus 5 squared.
Okay, so my problem is this. You told me this one was x plus 3, and now you're telling me this one is x minus 5? How are you going to tell the difference?
Do what?
How are you going to tell the difference? So you're telling me the sign of the middle number is going to give you the sign inside the binomial?
No, it's always plus.
This one's not plus.
That's what I'm saying.
But he's right. It has the sign of the middle number.
Well, yeah, because it has to be negative twice, right?
Mm-hmm. Okay?
Only if the end number is positive.
So tell me about this one.
That would be
X minus 7 squared. Excellent. What about this one? X plus 4 squared. What about this one? X minus 10 squared. Look, I'm writing a 2 over and over again. It's not showing up. What about this last one? X plus 1 squared. How do you feel with those? Fairly comfortable with those? Okay. Can I give you one more that's not quite as easy-ish?
Wait, can I see that last one again?
Absolutely. So what about this one? X squared minus 7x plus 12.25.
Oh, well, let's see here. What you're going to do is, this is going to be some rough stuff.
Don't you take 7 and divide it by 4?
Look back up and see if you can see the pattern. Where did this number come from?
X minus 3.5 squared.
Where did this number come from?
You divided it by...
This way.
You found...
Okay, what I'm pretty confident that he's trying to say is that you take the square root of this last number.
Oh, booyah.
Except what I heard Brady say was that you can divide the middle number by 2.
Both of them right.
Wait, they're both right?
I'm going to say he is.
No.
Very confident.
Okay, let's see. If I divide this by 2, is that 3?
Yes, sir.
If I square root this, is that 3? If I divide this by 2, is that 5? If I square root this, is that 5? Divide this by 2, square root this. Divide this by 2, square root this. Anybody see a good pattern going on here? So which one is right? Either one, right? You could use either one, whichever way you're most comfortable with. So that gives me, and she's correct, x minus 3.5 squared. Because you can either take half of this or you can square root that. Okay? Any questions?
This is for only perfect squares, right?
This is only for perfect squares, yes. Okay? Only for perfect squares. What do you notice about the leading coefficient of all of these?
6. It's 1.
It's a 1. Okay? We cannot do completing the square unless the leading coefficient is 1. That's going to come into play later, but just keep that in mind right now. Okay? So the problem comes in, quote unquote, problem comes in, because you're going to be going along on your problems, and you're going to get to this point. And that's all it's going to say. And you're going to have to figure out what goes here to make it a perfect squared trinomial so that you can get to your binomial. On all these ones I gave you just a second ago, it already had that third term, right?
Yeah.
Could we figure out how to get to that third term?
Easy
You just
peasy.
divide that
Well, you
term.
just
divide that
just
first
divide 6 by 2.
and then we'll square root it.
And I don't know if you realize that not a lot of people can see that. So good job seeing it. Okay, that's perfectly correct. Take that middle term, whatever it is, the x term, whatever number this is, and divide it by 2. Well, what's 20 divided by 2? What's 10 squared? 100. So if we're doing this problem right here, how am I going to find that third term?
Divide 6 by 2.
6 divided by 2 is?
3.
3 squared is?
9.
9. What about this one?
Negative 25.
Positive 25, sorry.
One of those is right.
Positive 25.
How do you know it's positive 25?
Negative 5 times negative 5 is positive 25.
So I take negative 10 divided by 2 is negative 5, and negative 5 squared is 25. So if I put negative 5 squared into my calculator, it's going to tell me positive 25.
Yeah. No. It's negative.
It doesn't, does it? You have to know what you're doing. You have to know how to ask the calculator to square negative 5.
Parentheses around the
Can you make an observation about the third terms of all of these?
They're all positive.
They are all positive.
So they all
Will I ever subtract that third term? Because I'm squaring something, right? Will I ever square any kind of number and get a negative number? Okay, so I'm always going to add something in that third blank, aren't I? Okay? Any questions about that? Okay. So here's the next part. We're doing all this in parts so that when I finally put it all together, there's no panicking or freaking out or anything like that. Okay? So that's the first little part. The second little part is right here. I'm going to give you an equation that looks like this. First of all, let me tell you this. This is standard form of a conic section. ax squared plus by squared plus cx plus dy plus e equals 0. Now, how do you feel? How would you feel if I said, here's an equation, what's a? Could you find that? How would you know what a was? Where's a sitting? Right beside the x squared. How could you find the c?
You look for the X.
Look for the x. C is always with the x?
Yes. Hey.
So, looking at this first equation right here, what's a?
X 1.
1, right? What's b?
1.
1. What's c?
Negative 3.
-3. What's d?
4.
4. And what's e?
10.
Okay? The a is always beside the x squared. The b is always beside the y squared. The c is always beside the x. The d is always beside the y. The e is always the constant. Oh my gosh, you're right. It is in alphabetical order. I should plan better next time and realize that. Sorry. Okay, so the next thing I'm going to ask you to do, and it's slightly more difficult, but not a whole lot, is I'm going to say, here's 4 equations. Tell me what shape they are. If I were to graph it, what shape would it make? What are my 4 choices? Circle, parabola, ellipse,
Freak out.
hyperbola.
Oh, yeah.
Okay? So you have to know the rules about what makes each unique so you can choose it out of a list. Okay? The easiest one to see is the third one on this list. How is the third one on this list different from any of the other ones on this list? It ain't got no B. In this case, it ain't got no B. Right? It only has what? One term that is squared. Okay? What shape have we studied that only has one term that is squared? Uh-huh. We're going to go back in a little while and make sure we write down why we know it's a parabola, so don't worry about that. Okay? For now, we're just going to say, well, let's go and write it down now. How do we know it's a parabola? So, one term squared. I need you to know a little bit more mathy way to say that, though. Okay? Here's the other way I need you to know. Either A equals 0 or B equals 0. One of those terms has to be 0, which would make it not show up, right? Either A has to be 0 or B has to be 0. Now, In my personal opinion, the next easiest one to see is the second one on this list. Compare the second one on this list to the first one and the fourth one. How is it different?
Yeah, mom.
Here, let me make it a little easier for you. Can I do that? What did we look for in this one?
The square.
The squared. Guys, it's even easier than it looks because the only terms that we're looking at are the squared terms. We can just look at the square terms and know exactly what shape it is.
Is it because the 3 is negative?
That's exactly what's wrong. Or what's different, not what's wrong. Okay? Notice in this particular equation, these two values, A and B, tell me about A and B. They are opposite. Okay? When A and B are opposite, it's a hyperbola. Now, we understand we're talking about opposite sign, right? Opposite signs. It doesn't have to be 5 and negative 5, although it can be. In this case, we have a 4 and a negative 9. The signs are opposite. Okay? In fact, that's what tells us. The signs of A and B are opposite. Deciding between the last two is relatively simple as well. Or it would be if I wrote something correctly. Can I fix something real fast? Mm-hmm. Otherwise, we're going to get it wrong. Okay? Let's make that a 4 instead of a 3.
What went on a 3?
You're going to be able to tell me that question in just a minute. Why not a 3? Okay? So I need you to compare the squared terms of the first one and the last one. And hopefully I just gave you a giant hint. Say it again?
They can't be the same. They can't have the same variable.
That's a good question or a good observation, but not quite right. What are the coefficients here? 1 and 1. They could be 2 and 2, or 5 and 5, or negative 6 and negative 6. But they are the same. What are the coefficients here? They're different. Okay? But they are the same what?
Sign.
Sign. Okay? So this one down here is an ellipse. This one up here is a
Circle.
circle.
So, why isn't it an ellipse?
Can someone tell him why the bottom one's an ellipse?
Because it's 3 and 4.
These
Not-
numbers right
not
here,
3 and
the
3.
coefficients of the x squared term and the y squared term are different.
Not the same.
Okay?
Okay.
So for a circle, what has to be true about A and B?
They gotta be the same.
So A equals B. And for an ellipse, what has to be true?
Gotta be different.
So how are you going to write that?
I just put A equals B and then put it across the.
So A doesn't equal B, but what?
Same sign.
They have to be the same sign.
What do you mean by same sign?
They both have to either be positive or they both have to be negative.
So,
If they're not, what is it?
No,
If they're not the same sign,
I've
it's a hyperbola.
Okay.
Does that make sense?
Please go in notes.
Yes. So, number 1, tell me what shape this is.
Give me a purple.
Nope,
Circle.
So I've heard circle and I've heard ellipse. One of those is correct, but I need you to tell me how you know it's one or the other.
Circle.
A and B are the same, so it is a circle. And they're the same sign, right? Okay? So what we're going to do now, we know it's a circle, that's good. Yay for us. Okay? We are going to complete the square on this equation. The stuff that we talked about earlier, this stuff, we're going to complete the square. Okay? The very first step that we're going to do is we're going to put together our like terms. Now, I don't mean combine them because everything that's able to be combined is already combined. But we're going to group our like terms. Like, I'm going to group my x's together. And I'm going to group my y's together. And at the same time, I'm going to get rid of this 51 to the other side because I don't need it where it is. Does that make sense? Now, per our conversation earlier, can I go ahead and put plus in that blank? And plus in that blank? So can someone please tell me how I'm going to complete the square on the x's?
Okay, so the first one is 4.
I'm going to take the middle term and I'm going to divide it by 2
So it's
and square it.
4.
4 divided by 2 is 2 squared. So if I put a 4 in this blank right there, if I add 4, I've now just completely changed the problem. And I'm not allowed to do that. What you got?
It is you divide it by 2 because why?
That's the steps that we take.
Okay.
Okay? Those are the steps that we take to complete the square. Is there any way I can fix what I just did without messing up this completing the square thing? If I added 4 to this side of the equation, couldn't I add 4 to the other side of the equation also? Does that keep things balanced? I'll be darned.
So it's like opposite line you add on this side and add on this side.
Absolutely. If I add on this side, I have to add on this side of the equal sign. Okay?
So
The next one's going to be what? 9, because I said 6 divided by 2 is 3, and 3 squared is 9. But now I've completely changed the problem. So I need to add a 9 on the other side. That's absolutely correct. Okay? Now, after I have my trinomial, what should I write? Remember what it's called? My binomial, right? I want something that looks like this. My binomial. What's going to go there? X minus 2 squared. Then I have my y's. Absolutely. Y minus 3 squared equals 64. Now, if I'm not mistaken, and I'm not, the working form of a circle reads x minus h squared plus y minus k squared equals r squared. So I'm done, with one exception. You're going to have to be able to tell me where the center is and what the radius is. Except in working form, doesn't it tell me where the center is? 2, 3. That's exactly right. 2, 3. And what's my radius?
8.
How do you know it's 8?
That's the square root of 64.
Very good. It's the square root of 64. Then we're completely done.
That's a lot easier than
It's a lot easier than it looks. And it's a lot easier if I go slower. Okay? Any questions about how to do a circle? How to complete the square on a circle?
Now,
You got it? Now, I'd really, really like to be able to tell you that if you know how to do a circle, you automatically know how to do a parabola, ellipse, and a hyperbola. But, right? There has to be a but, right? They're very similar. I don't want you to think you're going to learn a whole new way. They're very similar. Especially ellipses and hyperbolas, very similar to a circle. Okay? Parabola is slightly different, but you would expect that since it is so different as far as its equation goes, right? Only one square term. So we're going to do parabola next. Right? I should have given you this equation and made you guess what it was.
What's a parabola?
How do you know it would be a parabola?
Square.
Because there's only one squared term, right? Okay. So when we had a circle, the first thing we did is grouped all of our like terms, right? That's kind of what we do on a parabola. The only difference is we only have two terms that are really alike, right?
Could you put equals 0?
Does this equal 0? No, it equals y right now, the way it's given to you. This is not in standard form. That's a good observation, okay? And in fact, what I need is all the terms that are alike, those, I need them alone on one side of the equation.
Minus 16.
That's exactly right. Minus 16 from both sides. Now, for the record, there's actually two different ways to do parabolas, and I'm showing you the way that I think that you'll think is the easiest. The way you'll understand the best. If you don't understand this way, I'll be happy to show you the other way. You just have to come and ask me. Okay? Now, I need to complete the square. I'm going to give myself blanks to fill in because I don't like blank blanks. I want to put something in those blanks. Okay? What goes in this blank?
Oh, shoot. Easy. And the first one is 4.
No, we don't care about this one. We're not doing this one.
Oh,
We're completing the square on this one. We can't complete the square here because there's no square term.
25.
Okay?
25.
So this is 25.
Shoot, yeah.
If I add 25 on this side, I'm also
Adding it on the other.
adding it on the other as well.
Wait, well, what if you went the other way first?
You can't.
Yeah.
Guys, you cannot complete the square over here. There's nothing that's being squared.
Okay.
Okay? In order to complete the square, you have to start off with something being squared. Okay? So, what do I have on the right-hand side of my equation? Perfect square. So, what's my binomial?
5.
X minus 5 squared. Good. What am I left with on the left-hand side of my equation?
It's 4.
9. Y plus 9. 25 minus 16. Okay. Now, once again, if I'm not mistaken, and I'm not, the working form of a parabola has to either be y equals something or x equals something, whichever one that's not squared. In this case, it needs to be y equals something. So what do I have to do with this? Yeah, subtract it from both sides. Y equals x minus 5 squared minus 9.
So you're just moving it back to the other side?
Yes. So isn't this in working form now?
Yeah.
So for a parabola, you should be able to tell me the vertex and the direction that it opens.
Down.
Well, one of those is right. It's either going to open up or down. And hopefully that's a big deal to know that it opens up or down, because that's when my x is being squared, or when my y is by itself. Because if it was x equals y minus something squared, that means it would open left or right.
Yeah.
Okay? Since the x is being squared, we know it opens either up or down. I have to look at my sign of my a, and in this case it is positive, so it opens up. Okay? And where's my vertex? HK.
So it's
5, negative 9. Okay? Any questions about that? Now, I know that a lot of you, well, maybe not a lot, maybe that's not fair. Some of you feel like you're better at geometry than you are at algebra. And for that reason, I want to show you something real fast. Okay? Remember that very, very, very first example that I did for you? The very, very first example that I did for you looked like this. X squared plus 6x plus 9. And we decided if that wasn't there, we could divide this by 2 and make it 3 and square it, and that's where that 9 came from. Right? I want to show you something. This represents x squared, right? Have you seen algebra tiles before? These represent an x, so I need 6 of those. And that's all I was given at first, wasn't it? That's all I was given at first. So watch what happens. If I take those there, and I take those there, how many is it going to take right here to complete my square? 9. 9 little ones. Do you see now why we have to divide that middle term in half? And then why we have to square that number? Because see, it's 3 times 3. Does that make sense? Okay. I don't know if that visual representation will help everyone, but if it helped one person, it was worth it. Okay? And there's all these little baby ones that I could fill in and prove to you that it does make a square. Nothing's too much work for you.
For me?
Yes.
Me only?
No.
Say yes.
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 Ta-da! Guess how many there are?
9.
9. Okay? Does that help? Visually, does that help a little bit maybe?
Oh yeah.
Okay? If you didn't get it before, maybe that helps a little bit now, and if you got it before, maybe that just reinforces it a little bit. Okay? Alright. She has papers for you, if you'll pass those around real quick. I want to show you what problems I want you to do on the worksheet for tonight. Like I said, okay, first of all, how many conics are there? 4. How many did I show you how to do today? 2. Okay? So, yes, I did. I did circles and parabolas. Okay?
Oh, it's ellipses.
Ellipses and hyperbolas we'll do tomorrow. Okay? Please circle these numbers. Number 2. Number 2. Number 3. You got 2 and you got 3.
That's all?
No.
Oh,
I was waiting till everybody got their paper. 5 and 6. Please don't woe me as if I was a horse.
Are we supposed to like put what they are? Like a circle or
It says already. I want you to fill out this table right here.
Oh, neat.
And then this box right here will be extra if you choose to do it.
Oh, neat.
You already, if you wrote the notes down like you were supposed to, you already have all of that information in your notes.
Yep.
Okay? What's required is 2, 3, 5, 6,
100.
and the table at the top. Any questions?
None from my brain.
Except, never mind.
actually I have a question. I said